It's one thing to figure out what concentration will result from combining several different solutions, like we did for alligation medial, but it's another to determine how much of each solution you should use to obtain a specific desired concentration. The thing that makes this kind of problem tricky is that the addition of each solution adds to both the total amount of drug and to the total amount of solution. So it adds to the top and the bottom of the concentration expression. The problem can be solved algebraically using two equations and two unknowns, or you can use Alligation Alternate, which is also sometimes known as the tic-tac-toe method. In this tic-tac-toe method, which is shown here, the upper left corner is where you write in the bigger concentration, and the bottom left square is where you write in the smaller concentration. And the center square is where you put in the desired concentration, represented by the large C here. And you can find the parts of larger and smaller concentration that you need to mix together to get the desired by subtracting the smaller concentration from the desired. This gives you the parts of the larger concentration you need, and subtracting the desired concentration from the bigger. That would give you the parts of smaller concentration. We can see this in action with the example where we ask, in what proportion should 30% and 1.5% hydrogen peroxide solutions be mixed to prepare a 3% hydrogen peroxide solution? And so the desired concentration in this example is 3%. It goes in the middle. The concentration that's larger than that is 30. The one that's smaller than that is 1.5. We can subtract 1.5 from 3%. To find that we need 1.5 parts of 30%, we could subtract 3% from 30 to see that we need 27 parts of 1.5%. And so, well, 1.5 to 27 ratio of 30 to 15% is what's needed. Now, a good ratio doesn't have a decimal in it, so we can multiply the top and the bottom by 10 and get rid of the decimal, 15 over 270, and then we can reduce that by dividing by factors that they have in common. We immediately notice they have 5 in common. We notice after that that we can divide those answers by 3, and we end up with a reduced fraction 1 to 18. We tip on its side to get the ratio 1 to 18, 30% to 1.5% is how we'd combine those together to get a 3% solution. So we could also do this algebraically using two equations with two unknowns. And this would be the 30% solution, where x would be how much of it we're using. And this would be the 1.5% solution, where y is the amount we're using, to give us 1 unit of 3% solution. And the other equation would be that we can add x and y together to get 1. So the two should be able to add together to give 100% of the resulting solution. Okay, so simplifying this expression, we can separate the x and y from one another by subtracting 0.015y from both sides to get the x by itself. We can also solve for y over here. Y equals 1 minus x. And we can substitute 1 minus x in for y over here. So 0.3x equals 0.03 minus 0.015 instead of y, 1 minus x. And we can go ahead and multiply 0.015 through. And we can also multiply the negative through. And that gives us this expression. We can simplify 0.03 and 0.015 negative by subtracting and get 0.015 there. And then combine the x's by subtracting 0.015x from both sides. And that gives 0.285x on this side and 0.015 on that side. Divide both by 0.285 and we get a value for x of 0.0526. If we take 0.0526 and put it up into here to our second equation. 1 minus 0.0526 is 0.9474. And so now we can set up an x over y of 0.0526 over 0.9474, divide top and the bottom by the smaller of the two decimals, and that gives us 1 to 18. And so there's our proportion. 1 part 30% to 18 parts 1.5%. Here's another example where instead of just finding the ratio of the two concentrations that should be used to give a desired, we can try to find a specific value. So how many milliliters? What's a specific quantity of 5% and 20% that we should use to obtain 240 mils of 15%? So in order to find a specific quantity, we have to have at least one of the quantities given to us. And so using the tic-tac-toe method, we have the desired concentration in the middle. We want 15%. We have the one larger up in the upper left. We have the smaller in the lower left. We subtract 5 from 15 to get 10 parts of 20. We subtract 15 from 20 to get 5 parts of 5%. And then actually, if we want to use the middle concentration in our calculation, we can sum the two parts together to determine how many parts are represented by the 15%. And that can be important in some of the proportions we set up. And actually, it's important in this one, because the quantity that we're given is the quantity of 15%. And we need to associate the quantity of a percentage with the number of parts of the same percentage. So it was important that we added the two parts together to figure out how many parts of desired concentration we have. So there's 240 mils of 15%, there's 15 parts of 15%, and we want to, let's start with the number of mils of 5% that we need. Set up the proportion, so how many mils of 5% if there are, 5 parts of 5%. Okay, so crisscross, and x is 80 mils. 80 mils of 5%. And so we can set up the same kind of proportion for the 20%. We could do how many mils of 20% if there are 10 parts of 20%, and set that up with 240 over 15. We could do that. Or, knowing that there are 240 mils total, we can just subtract 80 from that and find that 160 mils of 20% would be required. Okay, so there's our two answers. We could do this algebraically with two equations. 5% x as a decimal, 20% y equals 15% times 240 mils. So x and y represent what's the quantity of 5% and 20%. And again, we can isolate x by itself, get y over here. Our second equation is that you can add the two quantities of x and y to get a total quantity of 240. So y would be 240 minus x, and we can substitute that in for y. So 0.05x is 36. That's 0.15 times 240. 36 minus 0.2 times the quantity of 240 minus x. And we distribute that and can distribute the negative sign as well. So we end up with 36 minus 48, that's negative 12, plus 0.2x equals 0.05x. Combine the x's by subtracting 0.2x from both sides, and now we have negative 0.15x equals negative 12. Divide both sides by negative 0.15, and we get 80. 80 mils of x, which is the quantity of 5%. So 80 mils of 5%. And y is 240 minus that value. So we put 80 in there. 240 minus 80 is 160 mils. And y is the quantity of 20%. Right? So 160 mils of 20%. All right, so before having you do problems on your own, we're going to do a second video where we split this up and we talk about fortification separately.